Welcome, guys.
Hello.
So, Dmitry, can you kindly introduce our speakers?
Yeah, sure. So Dave and Ivan are London-based independent consultants and coaches. They were doing TDD and extreme programming before it became trendy and everyone put TDD on their CVs. And they worked with Kotlin since it was released. They are the authors of http4k, excluding open source contributors. And I worked with them in a couple of companies using http4k. So that's how I know them. Hi, how are you doing?
Nice.
Hello.
David, I think we cannot hear you. Are you muted by any chance? How about now?
I am muted, yes. Thank you very much. Okay, yes. Good morning, Dmitry. How are you doing?
Yeah,
Hi,
it
yeah,
happens.
I'm good.
So, HTTP4k, it's pretty new, and we've had a few talks recently about micro frameworks. So, would you position it as a micro framework, or do you not use such buzzwords?
So I think, should I also do this, Ivan? Yeah, so I think
Yeah, go
we
for it.
try and think of it as a library rather than a framework. So we really want to make something, well, I suppose what we really wanted to do is we're really old and we've been around for such a long time learning about all the things that are out there that we thought, hey, why don't we make something that we want to use? And so that's kind of what we did. The library it's not that new, so it's 2016, I think, or 17, maybe. But it's just kind of grown. We started it like using it in one company, and then it's all in lots of companies. So whenever we go places now, people are using it. It's great. And it's just grown, really. I mean, we started with one module with 30 lines of code that Ivan wrote with another guy called Ivan Moore on a hack day. And now we've got 50 modules and tens of thousands of downloads a day, and it's all gone a bit crazy. But yeah,
Well, it is impressive.
I mean, hopefully, it's a library that developers love to use.
I sure hope so. I have not tried it yet, but I'm pretty sure that the next time I start something from scratch, I would. And one question to you as well, Ivan. So your bio says that you are a practitioner of extreme programming like TDD and pair programming. So did you use pair programming and TDD while developing HTTP4k?
Especially at the beginning, it started, like Dave say, on a hack day, and it was one day of pairing, and 60 lines of code later, we had something that we could pack into a library. So a lot of the is pairing. We've been trying to run a lot of mobbing sessions lately as well. Dimitri's been in a lot of those where we play with ideas and we try to get the best of them and incorporate in the framework.
Cool. So I guess let's start with the talk then. Let's get the slides on the screen. Good.
Cool. Right, I'll begin. Brilliant. Okay, good morning, everyone. I can't see you, but you can see me. So welcome to Writing Test-Driven Apps with HTTP4k. Yeah, I'm David. I'm going to be doing like the talky bits and the slides, and Ivan is going to be doing some coding. So that's kind of how the split's going to work. So the basic aim of this talk is to identify like pain points that teams come across when developing test-driven apps, basically, and see what kind of techniques we can use to help. The focus here is on using HTTP4k because we wrote it, but generally most of it can be seen as food for thought, and all the stuff we cover here can hopefully be used in whatever web framework you're using, basically, or whatever web library. So this is, so it's going to be a bit of a whirlwind tour. It's going to be me and basically doing it. He's going to code and I'm going to talk. So what problems are we trying to solve is the kind of fundamental question. Well, we're looking to write applications that are easy to write and test, right? That's our main thing we want to do, but also to maintain. And as part of this, we kind of tend to find that what tends to get, what gets ignored occasionally is the build. And it's here that kind of things can really problems can start to creep in, especially with testing. Builds are obviously negatively affected by test suites, which are slow. That might not be a problem when you got your shiny application and it's got like one endpoint and 2 test cases. But by the time you've got like hundreds of test cases or thousands of test cases and hundreds of endpoints, then the speed of builds really is going to start hitting you. So that's going to also affect your ability to release and your mean time to recovery, etc. So you got to keep a tight grasp on your kind of build times. The second thing that tends to plague builds is like flaky tests. I'm sure everyone's watching this probably got a couple of flaky tests sitting somewhere in their build. You can see on the slide you've got the classic like testing pyramid, and as we kind of go up that testing pyramid, what tends to happen? The test tends to get either more complex or slower to set up, and that happens. Yeah, it's kind of complexity and it's flakiness as well, basically, especially when you get to that UI layer when you're testing against third-party services. Now, your classic talking about third-party services. If you're testing against them, the classic kind of stub service that you kind of get by a vendor, they're more generally pretty crappy. They've got unreliable uptime because some dev will randomly deploy to it. They're slow. You can't tend to it easily because they rely on lots of button clicking. Alternative to this is like that you might stub out some adapter code, which is fine, but where you might kind of get some kind of coverage. But what then can happen is that transport code, which actually is a lot of the time really quite useful, is actually missed during testing. So what we want to do is actually extend the test coverage all the way through the kind of protocol and all the way to the other end of when we're talking HTTP. Thirdly, I suppose one of the promises of microservices is that it's effectively zero away. We can just toss out the implementation and rewrite it from scratch. However, what you really want to do is when you're doing that is to actually keep your current tests and then rewrite it and maybe then rewrite your test. But what you tend to find with lots of frameworks is that there is coupling between the test framework and the implementation framework. So if you toss away your implementation, your tests become basically useless. And the last thing we find when we're testing is that as you go up the pyramid, the kind of technologies tend to change, or the levels of abstraction or complexity again. That means basically you can't reuse test cases as you kind of go up the test pyramid. So the technologies change, and you have to learn lots of different abstractions basically. So I suppose at this point we say, what are the characteristics of a good test, basically? So next slide, Yvonne. Well, the fundamental premise of those tests is that they should be easy to work with. Tests should be quick and reliable, and for unit tests at the bottom of the testing pyramid, that tends to translate as meaning running in memory with no network or database access. For HTTP microservices, it might mean you're testing a transport layer without binding to a port, and this helps with both speed and parallelization of tests because you haven't got ports that are bound, and then you won't get port clashes, which is a massive flaky test kind of risk. Another thing that technologies tend to sit with is some kind of specialized testing infrastructure that's used to test apps written them. This can be slightly magical, and as I said before, it kind of gives you that coupling between the implementation and the tests, which kind of dents the ability to throw away your code. And lastly, test code, like prod code, should be kept dry, so we maximize the ability to reuse it in other context. For HTTP tests, this means we should be able to use the same test code to drive not only fast unit tests, but then against maybe applications running against or in browser tests, etc., etc. So the question is, what if we could take those characteristics for good fast unit test and then move them up the testing pyramid? How about being able to test your entire application or suite of applications end to end in memory? And then hopefully we'll show you today that if you apply the correct paradigm, that's actually possible. So onto a bit of HTTP4k. What do you need to know about HTTP4k? If you're not familiar with it, I'm going to tell you just enough to get you through. Don't worry, it's all very simple, especially when you've seen the code, when everyone kind of starts in a couple of minutes. So what is it? Well, HTTP4k is like a pure Kotlin web library, and it's based on the server as a function paradigm, which came out of Twitter in 2012. The main concept is that all HTTP services are modeled as a simple function, which is a signature from request to response. And we can see that modeled here with the type alias. So it's not even an interface. You can see the definition on the slide, and it's worth pointing out here that everything in HTTP4k is immutable. So all the HTTP messages are immutable, and that we kind of encourage good kind of functional practice like immutability and kind of expressions over blocks, etc., etc. So it really helps to kind of comprehend what's going on because you don't get that mutation of state. Now the secret sauce, I suppose, if you call it at all, of server as a function is that both HTTP servers and HTTP clients are basically represented using exactly the same interface, which is the HTTP handler. So having this uniform client-server API allows us to shift from the model on the left, where you might have lots of different technologies talking to each other. So you might have a servlet API coming in, and then you might do some stuff, and then you actually use an OK HTTP client to make outgoing HTTP calls. Right? So those two APIs are different, and they're incompatible. So you've got more than one API to learn initially, and there's kind of that complexity of jumping abstractions potentially. Now, in http4k, we move to the model on the right, which is basically the client interface and the server interface are identical. This means basically you can treat entire apps or suites of apps or HTTP clients, and they're in a completely interchangeable way. How are we going to do that, and how is it going to look when we write it? Well, we're going to find that out in a sec. Let's introduce the app that we're actually going to write. So, Yvonne, can I have the next slide, please? Excellent. Quick overview here. We're going to write a really quick app. The basic requirements are an app that analyzes sentences. There's going to be 3 endpoints. The first of which is going to count the number of valid words in a posted sentence. We're also going to want to measure the popularity of our service. So there's going to be an endpoint which exposes the number of times the app has been called. And the last endpoint is going to provide a breakdown of the characters of valid words in a posted sentence. We'll go through those. They're all quite simple. And we're also going to be integrating a third-party service dictionary, which is basically a remote HTTP service like any that you might call from AWS or Google, etc., etc. So that's probably enough of me. Let's dive in and start coding. Ivan, over to you.
So, cool. Let me just pop the code in. So, just full disclosure, this is a pre-recorded coding. I'm just going to narrate basically, and pause when necessary. So, we're starting this with the test-driven approach, and for that, as usual, you start by creating a test, and this is our sentence analyzer test. So this is what's going to hold the main tests for our application. And we're going to start with the test case for the counting word requirements, where you post a bit of text, and it will tell how many words are in that sentence. So our application as a function is just an HTTP handler, and as you can see, we use just a simple live template from IntelliJ to pop a new function there. And as you can see, function it takes a request and returns a response. In this case, the status OK. And that's all you need to start creating an application. And to use the application, you need to create a request. And a request in this case is, for example, a post to the /count URL. And this is pretty much a data class in Kotlin that is immutable. You just put some information there to be able to identify what the request is about. And that's what you're going to use to invoke your server. So for our test, we also need a body. In this case, we're going to use the lazy cat. And what we have next is how you actually get a response. Because HTTP handler is just a type alias to a function, it means you can just call it, and like any other function. So far, we didn't use anything else apart from 2 data classes and 1 function. So to obtain a response, you call the function, and there you go. And finally, to have an actual test, we need to assume what the response should look like. So in this case, I'm going to pause there. We can assert that the response that we get will have status OK, but we'll have the body with the number 4, which is the number of words on that sentence. So we have some specialized hem-crest matchers, has status and has body, but that's effectively doing response.status equals OK and response.body equals 4. So we're going to run this test to start with. And as expected, it fails because our handler doesn't do anything yet. And we're going to try to make this work now. So the way we can do that is both request and response have body. That's basics of HTTP. So the way we're going to make the test pass is by getting the body from the request. We split using space. and we get how many entries we actually have. So that's the one line of code to get the response that we expect, and we run the test again, and it passes. So just a quick recap. So all we have so far is a function, 2 immutable data classes, and some assertions. So there's nothing really much to do that. So what can we do next? Let's try to refactor a bit in this phase, and we're just going to extract our function there as in a function to create it for us. So the sentence analyzer app will produce our application, which is the request response function. So once we have it there, we can extract and move it out of the test, and we can also move to its own file. And we just run the test to make sure everything is okay. So there you go. So this is our application so far. Those 3 lines of code that return a response the way we expect. And if you notice, refactoring in IntelliJ nowadays, if you extract, even though we defined originally as an HTTP handler, it won't be smart enough and will put request response, but it's just a type alias. So it doesn't have to, there's not much more to it than just a alias, really. So now we have a function, we have a test. There's not much going on there. What can we do next with that function? To make it really useful, we probably need to be able to run it as a real server. So what I'm going to show next is how can that be done. So to create that, the only thing I'm doing is I'm going to create the function, and then we have extension as a server, and we're using Sun HTTP as a backend, and we're going to start that on port 8080. So ironically, http4k doesn't do any network code. We create this abstraction to define HTTP and use the server as a function approach, but we just leverage existing technology. So if you have Sun, which comes with Java, or Apache, or Jetty, or Netty, or Undertow, or Kato, or change the parameter to the S as server, and you can basically run using a different technology that you're more comfortable with. There's no point reinventing the wheel at this stage. So I'm going to run this just to triple check that this does what we expect. And I'm going to go to the terminal and curl it. So if you curl past post with some data, I'm going to use hello world, and I'll run this, and that for hello world it will return 2, because that's our functionality so far. So we have an application that works, and so let's try to do a bit more. Let's create a second test now for some new piece of functionality. So another requirement that we have is that when you call the /count, we're not only counting the words and returning that, but we're keeping track of how many times that endpoint has been invoked. And there's going to be a separate endpoint that will tell us how many times the application has been invoked. So this is the /calls, and then see that I'm calling directly. I'm not creating the request individually. So the request using get to /calls should return okay, and should have 0 to start with, because we just created the application and we never invoked anything else. But if you post to /count, how we've done earlier, that means that if we assert again the same thing, now this /calls should return something different. Instead of 0, it should be 1, because it means that we use the counter just once. So we're going to run that first and see what, it doesn't return anything. It returns okay, but it won't have the right body, because there's no concept of different endpoints so far. We just have a function that it takes a request and try to count the words. So let's look at our sentence analyzer. So this function has a key missing part from http4k that is routing. So we need to be able to identify what the request is for and use the appropriate logic to reply. So I just cut the existing handler, and I'm a particular route to /count, which is a previous function. And we then can define the path and the method that it takes, and that takes a post to count. And our endpoint will be there as well. The /calls, we're creating that now. It will get just a response. Again, I'm using the same live template just to create a simple function, but I don't know how that should work yet. So I'm just creating a body not implemented yet, just to make sure that my test gives me the correct feedback and everything else is still working. So I'm going to run the test again. And the sentence analyzer yet. So I can tell that the routing bit is working, but it's still not doing what we want. So I'm just going to do a bit more refactoring there, replace the type alias, and I'm done so far. So now we have to figure out how we can put this kind of functionality. So counting how many times a handler is invoked seems like a cross-cutting concern to me. It's not something that I will put the logic straight in that handler, because I may be able to count points being invoked as well. And so in that case, I feel like we need some other concept to be able to do cross-cutting middleware-like functionality in our application. So Dave, how do you think we should approach this?
Excellent. Okay, thanks, Ivan. Right. Okay, so I'm going to need the slide, and then so in order to implement this, we're going to introduce the other concepts of HTTP. There are only 2 or 3, and this is called a filter. A filter is effectively another function. It's just another type of function that we already had. HTTP handler, which was just a function of request response. Filter is a request or is an HTTP handler to HTTP handler function. And what are they? So filters are basically used to define middleware. You might also recognize them as the same pattern from servlet filters. It's the same pattern. The idea is still the same. It basically allows you to decorate the functionality of one HTTP handler and return another decorated HTTP handler. You can stack them together or you can compose them because they're just functions. You can use the then method. You can see that on the screen. You can see that we've got 2 filters. We've got a logging and a security, and then we can do logging.then security. That just means that logging will be applied, then security will be applied. And because it's a wrapping behavior, you can apply, because it's decoration, you can apply behavior before and after the call. So we would, obviously security would probably log before, we would do security before a call took place, and logging we would do after its call had taken place, because that's the kind of we want to kind of log what happened. And then so a filter, if you compose it with another filter, you just get another filter, and if you compose a filter with a handler, you get a handler that has been decorated. So this is just simple functional composition that's taking place together. So everything is like really, really simple, and the APIs are consistent, and so because things are because it's a cross-cutting concern and it's just a function, what it means is we can actually test it really individually and really simply as well. So now we are, Ivan, let's use a filter to implement the call counter, shall we?
Cool. So we're going to leave the test failing as it is for now, and we're going to take a slight detour to try this filter. So we need this call counter filter, and it's something that just counts the number of calls to any HTTP handler, and we can apply this filter then later to make the other test pass. So the mechanism we're going to use to accumulate the number of counts is an atomic integer. We're going to create our filter, and we know that this filter can be applied to a handler. So we have the call counter, which is going to be our filter, and we do then any handler. It doesn't really matter. But if you do a couple of requests for the handler, and again, method doesn't matter in this case, path doesn't matter in this case, we can assert that our counter has been modified and is no longer 0. In that case, we call it twice. So we have 2 instead of 0. So I'm just creating the function to produce the filter for me. And like the handler, I'm using a template, a live template, to create the basic boilerplate for the filter. In that case, filter is an interface, is a function interface. And now we can apply the extension. So I'm going to pass the parameter. So we know it's going to need a counter. And we know the filter, the basic of the filter. In that case, the filter does nothing. The only thing it does is it calls the next thing in the chain with the request. So it, in that case, is just a request. So as expected, it fails because it didn't do anything with the counter. So let's stop. So just to recap, the filter there, the next is the next filter is the next HTTP handler in the chain. And it could be passing to new filters, you don't know, but you just invoke the next one with the request. And what it returns is a response as well. So if you want to manipulate the response, you can just capture that, do some manipulation and return that instead. So now we're going to try to make this work. So we have it already. So it's just a case really of getting and incrementing. Doesn't get much simpler than that. So I'm going to run it again, and it passes. So now we have a call counter filter that it has a dependency on some atomic integer, but it can be used to keep track of how many times any HTTP handler has been invoked. So let's refactor this a bit and extract to its own file. So it's all good there. And go back to the other test. And now we have the other test. Let's just make sure it's still failing. So that's the state we left it before. So it is failing still. And now we go back to our router. We're going to change that to become it can't be an expression anymore. So we create a block because now it has a dependency on that atomic integer, which we're going to create now. So there you go. So this atomic integer is going to be the place where we're going to hold the state of how many times the HTTP handler being called. And as you can see, we're introducing that call counter now after the post and before the HTTP handler. So we know that we have to apply this filter before that the actual functionality of the count is invoked. So we're going to create the filter and we use then, and that's it. Because call counter, a filter will still return an HTTP handler when you pass an HTTP handler. In this case, the type signature remains the same and nothing breaks. And also, now that is being applied to the count handler, we can get the state back from the counter, the atomic integer, and return that on the other endpoint, which is the one that we have currently failing. So let's run now and see how it works. And it passes. Yeah. So that's all we have so far. Let me just see. We're going to go back to the test. So now we have the 2 tests for our application. Our application covers 2 of the functionalities that we set out to implement. And that's okay for now. We're just going to do, in that case, yeah. So there you go. So that's where we are. So what we've achieved so far is we have some tests that run completely in memory, and we can get a server that already runs. You can have a main, and you can just put it to run and deploy. So we talked earlier in the introduction that we'd like the tests to have the ability to be able to run in different contexts. And I think that's a bit of where the power of http4k and server as a function starts to appear. So more interesting.
Okay. Let's get a slide. Brilliant. Thanks, Ivan. Yeah, so as Ivan was saying, so one of the problems that we had on the list was we want to be able to reuse that test code in different contexts across the testing pyramid. So not just in unit tests, but also integration tests, etc., in contract testing, etc. If we could consider two different types of test case we want to write for, say, unit tests, and we want to run everything in memory, we also run the same interactions on a network, so against the server which is running locally or maybe on another machine or somewhere on the internet. Luckily, so the uniformity that comes with the server as a function model makes that a snap really easy to do. So, and without introducing a bunch of like different heavy test infrastructure. What we can simply do is replace the application of the test, which is an HTTP handler, remember, with an actual HTTP client, which is another HTTP handler. And then we just completely reuse test logic by just abstracting it away. So one way to do this would be introduce a test contract as a superclass with two implementations, one supplying our in-memory app as the HTTP handler, and the other supplying the configured HTTP client. So yeah, you've got that reuse, the common functionality exists in the test contracts, and just the only thing those two subclasses are doing is supplying that HTTP handler. But let's see how that works. Okay, Ivan?
So here's where we stopped. So let's now, we're going to use IntelliJ to do the heavy lifting for us of creating a superclass. And we're going to call this the sentence analyzer contract. So we can use the same test at different levels to check that our functionality still works. So we're going to make the app, the HTTP handler, the main HTTP handler abstract, and we're going to move the tests to the abstract. One thing bearing in mind with IntelliJ is that although the refactoring mostly works, it doesn't get the imports right. So I had to copy and paste the imports to make it work. So because it didn't do in one step, I rerun the test just to make sure everything is okay. And now we have a contract, and it only has one implementation, which is a previous one that just runs in memory against our objects. So to make this a bit more interesting, we're going to create the next implementation, which will be a remote test. And by remote, we means instead of calling everything in memory, we're going to actually use a HTTP server and an HTTP client to make sure that over the network, our application still works. So for the app in this case, and that's where the fact that HTTP handler is uniform, it means that we can just swap our server with the client. And I'm going to go through and explain what that looks like. But our server is still the same sentence analyzer app that we created originally. And as you can see, I'm going to have to run that as a server, and I'm going to run on port 8080. Very similar to main, actually exactly like the main. The only extra thing that we need to care about, that now that we're running a test that really starts up a server container, we need to start and stop before and after the test. So just to recap that, so we're going to need the server as it was before, and we're just going to start that server. And the actual app from our test point of view now becomes a client. And the way we set up this client is we have a client filter to set the base URI. And setting the base URI there means that we're always going to call it, no matter which, the requests, as you saw before, they were all just a path to the endpoint. This filter will basically put the host and the port in the request and make sure that we call in the correct server. And then we're going to use OKHTTP as our client. The same way as the server, we didn't do any networking code in http4k to implement the HTTP protocol. What we do instead is we leverage things like Apache or OKHTTP, or I think Jetty has a client as well. And in this case, we have an HTTP handler that if you invoke that with a request, the request is actually sent to an actual server. So let's run our test and see what happens. So now we have it has two implementations now, as you can see in the test result. That's the sentence analyzer test and the sentence analyze remote test. So one thing that's like very important to point out is look at the difference of timing of running an in-memory test and an HTTP based test. So most people are used to, if you're using Spring, for example, and you start some server, you will have some container, and you will go over the network. But as you can see, you get an order of magnitude quicker tests if you just run everything in memory. And we allow people to run everything in memory because you're just dealing with functions and objects. So there's no network, there's no file system, there's no container startup or anything. So instead of 150 milliseconds to run a test, we can run in 8 milliseconds. The only downside of this kind of test, well, one of the main downsides is that now you do have a source of flakiness. First, because you're dealing with a network. So if you already have something running on that port, it's not going to work. You're going to get some errors starting that test, and that's quite common. And the other problem as well is that test has a fixed port, which means that if we now start adding new tests, we have to worry about which port each test is using and make sure they don't clash if we want to have any hope of parallelizing our build, for example. Otherwise, you're just going to have to count on luck to make sure that the tests don't overlap each other. So that's one downside of running with the tests. You guarantee to have flakiness if you don't be careful. But on the other hand, most servers nowadays support a dynamic port. We're just going to use a simple trick there. Instead of running on 8080, we're going to run on port 0. And the server now allows us to get the port dynamically. So this should take us a long way of avoiding flakiness and allow tests to run in parallel, because for every time you start a new server, you're going to get a port that you don't care about which one it is. It's going to get a free one. And now all our tests are passing, and we have the same test and at 2 different levels, integration and unit. So Dave, what should we build next?
Okay, thanks, Ivan. Right, so we've only got one endpoint left to make. That was basically the endpoint to analyze sentences. You can see the contracts that are put onto the slide there. It's a post /analyze, and it's just taking some random text to the body. And the output is basically a breakdown of all the counts of the letters in those words. Okay, that's pretty much it. We're looking simple. Let's get coding.
Okay, so right. So as you probably guessed by now, we're going to start with a test. And the new test for us is for the analyzer. So as you can just bear in mind, we are adding the tests already in the contract level. It means that any new functionality that we put will run on the 2 different contexts. So we're going to start that in this case, there is, for this test case, we expect some JSON response. So we are starting with a hand roll JSON, and we're going to start with an empty one because it's the simplest one to write if you're doing by hand. So for the new endpoint is going to be /analyze, and if you pass nothing, you will get an empty breakdown of that sentence. And using the same matches as before, we can tell that it has a status OK, and the body is the JSON that we just wrote there. So let's just run the test. And normally when we're doing development and we're doing test-driven development this way, even though we're adding the test to the contract, during the initial steps, we just run the in-memory one because it's quicker to get the feedback. And if that fails, we know we're going to have to fix that anyway. So we run that, and because we're using routing already, it tells us that we get a 404 route not found. And that means that /analyze doesn't exist yet, or we typed it wrong. We know that it doesn't exist because if you look at the roots, there it is, it doesn't exist. So we're going to add it first. So /analyze will bind a post because we're going to pass some data, and it will return some, and we'll return some response. He did skip. Okay. Right, let me just get to the... So one thing that we notice on that, and I'm not putting the implementation, the test is still failing, is because I really don't want to write JSON by hand on my server. I think that's not the best approach at all. We wrote on the client, we try to write a string, a JSON as a string, and pass it through, because it's bound to create issues. So it's not only less readable, but it's definitely going to be less robust, to say the least. So for that, we should try to leverage some mechanism to do something a bit more clever. So Dave, what can we do in this case?
Thanks, Ivan. Right. Okay. So yeah, the good news is we have another tool in the toolbox, and we can introduce another HTTP concept here to help us implement this kind of JSON message handling, and that's what's called a lens. So a lens is basically it's just a function. It's like all the other functions, most of the other concepts in HTTP4k, and it's got its parentage, I suppose. Its heritage is from Haskell. That don't let that scare you. This is actually a simplified version thereof. So what is a lens? A lens is basically two functions in one. So a lens, the job of a lens is basically take an object and a type. And one of the lenses called extract, one of the functions is to, one of the lenses, one of the things called inject is to take an object and HTTP message and inject that object into the HTTP message. So that message could either be part of the body, or it could be a query parameter, or it could be a header parameter. And the other function is called extract, and that just takes an HTTP message and a type. So what will happen there is that if you apply that lens to a particular HTTP message, it will attempt to extract that type of the object of type X from the message. Basically. So it's two different functions that you can apply in two different ways. Basically, remember everything's immutable. So whenever you call that inject method with the HTTP message and the value of type X, you'll get back another HTTP message with that thing injected in. That's kind of like functional immutability. So inside HTTP4k, there's loads of different implementations. As I said, there's like form bodies. There's bodies. There's form bodies. There's JSON bodies, which you're going to use here. There's queries. There's headers. There's a multi-part, all that kind of stuff. So what you can see at the bottom here. This is how you would use a JSON body lens, basically. So we're going to leverage Jackson, or you can also use JSON, or Kotlin X serialization, or Moshi. Basically, you can just swap out, like with the servers and the clients, you can just swap out the implementation literally by changing an import. So here you can see what body.auto analysis and .to lens. So what that's going to do is going to give us a thing that can inject and extract an object of type analysis from the body of an HTTP message. So that's probably that's a lot of words. It's probably more simpler to see how it is when it's coded. Ivan, do you want to show everyone?
Yep. So let's show how that looks in practice. So we're going to make our empty sentence analyzer pass. That's our failing test so far. So first we create our domain object there for the analysis. And there you go. And we're going to change that to define a lens that allow us to inject that object into the response as JSON. So that's the body for lens, and we import that. And that means for the response, we have an option to do the with lens of analysis of empty map. So the with lens of analysis is mostly syntactic sugar. If you just get the lens and you apply directly on a response body, it will run this. It will basically apply and inject anyway. So if you run the test now, it passes, and that's the simplest case. We have an analysis for empty map. So in terms of format, everything is in there. It's also bear in mind that we tried, for this example, to make things simpler to read, we are doing our domain logic straight in the handler. We normally don't recommend people to do that. You normally create some better domain abstractions to do the logic and leave the handlers just for this translation of HTTP to domain and back and forth. But for this demo, we decide to keep it simple. So with this test passing, it's probably time to create an actual test for analyzing a sentence. So we're going to do that by creating some expectations, and I have some canned response. We don't expect to write JSON like that, but just to prove that what we're getting out of the server is JSON and it is what we're expecting, I'm putting the actual response there, and I can talk about better ways to do that in a moment. And we're going to call the same endpoint, but this time the body will be a proper sentence. In this case, the same lazy cat. And the assertion is pretty much the same. We expect OK, but now the expected body is different. It should have a JSON with some values there. So let's run this. And of course it fails because we're going to return something empty. We can see the empty JSON there. So I think we better go and try to make it work. So back to our app. We have the lens there. We just need to put the actual business logic of creating the analyzer, which luckily for us in Kotlin, strings are just a collection, it's just a list of characters, and we have enough collection manipulation functions in Kotlin that allow us to, in this case, group by the character and then map its values to get the number of elements for each character, which give us pretty much the analysis that we're looking for. So with that extra line, we actually implement the functionality that our test requires. And there you go, we run that and it's all working. So let me just pause here. So what we got so far is the test is passing. It's probably not the best test because it's using JSON that's being handwritten. So you have probably two options in this case. The lens you can use for the test as well, because the lens are shared and can be used both to inject and to extract things from a response. So the same lens that we defined there can be used on the test, and you can assert by recreating the domain object by pulling the JSON out of the response. You can also use a technique like approval test where you would save that response into a file and make sure it's okay. So you don't have to write it. You just need to keep an eye on it and make sure that it looks correct. So that pretty much does our analyze functionality. So what should we build next, Dave?
Okay, fantastic. Okay, so yeah, so the next is kind of basically going to introduce the dictionary. So the thing we haven't done, we actually haven't quite met the requirements for the count endpoint. So the requirements stated that we would use like this third-party dictionary API to validate that each of the word exists. So there's like details of the API here. You can see it's just running on api.dictionary.com port 10,000. In order to use this service, we're going to create a domain client to like encapsulate our usage of the API. In this case, we can just wrap an HTTP handler to make the HTTP calls for us. And it's going to translate response into something meaningful to our system's domain. We should also try and create a contract test, which allows us to explore and validate our usage of the API. So we can run that as part of our build to make sure that both APIs are compatible and we haven't actually broken anything effectively. That's enough for me. Let's talk. Let's code.
Yeah, so the requirements is simple. What we want is to use an actual dictionary and only count valid words. So since we already have a real dictionary server running somewhere that we don't know, let's just make sure that we understand how it actually works. So for that, I'm going to command line. In the terminal, I'm going to curl that server just to validate my assumptions on how this API looks like. So if I call the API, I'm going to call with foo. And so if I do API dictionary.com/foo, I know that that's an invalid word. And as expected, it returns a 404 not found. And I'm going to try the same now with the valid word. So I know that is a valid word and it gives back OK. So now I have a solid understanding of what a real dictionary server looks like, which means I can create my client for it. So for the client, we're going to call that just dictionary, and we can start with the test that checks a valid word. And for clients, we always try to start with an actual abstraction. In this case, we're calling it dictionary. We don't use just an HTTP client. because we want to be able to represent in domain terms what we're trying to achieve. So we know that if dictionary will have a method is valid, that if you pass it will return true. So let's create it here. So dictionary, it needs a function is valid that returns a Boolean. And to start with, because this test is so silly, I'm just going to return true. So I can run this test just to make sure that it compiles effectively. So I'm testing that everything is compiling fine. And if I fake the return, it will actually pass in the first test. So a more interesting test now is, let's check for a different word that we know is invalid. In this case, we're going to use the same we use in the terminal, full. And we run again. And in this case, it won't work. And we know we're going to need to use the real dictionary to make this work. So the way we're going to talk to that is using the same client that we use in our remote test to test our own server. So it's a client filter first to enforce the URI. And the URI for the dictionary is the API dictionary.com, port 10,000, and then an OK HTTP client. So we know this HTTP, every time we send any request, it will basically post this request, well, post or get, do this request, it will make it reach the actual server. So the dictionary abstraction will have a dependency on this HTTP client to work. And we're going to use the HTTP client and do the request in the same way we did in the terminal, where you pass the get with the word that you have as a parameter, and you analyze the status, the HTTP status, to tell if that word is valid or not. So as we have there, if it's okay, we can tell it's true. If it's not status okay, we can say it's false. And we can run that test and it passes. So talking to the real server, we know that our dictionary abstraction does what we expect. And now we have a client there that we can actually extract to start using somewhere else. So we do a bit of refactoring, remove a bit of code that we don't need, and move to its own file. So this is already a test. Is a server, is a client with an abstraction to an existing real server, and we can reuse that somewhere. And that gives enough confidence that we could just plug this into a server. The only downside is now our test that was fully in memory wouldn't be all in memory anymore. We would probably guarantee to add the source of flakiness by talking to the third-party service on every test for our sentence analyzer app. So we need a better way to approach how we do this kind of integration with third-party service when we want to apply. So Dave, how should we approach this?
Thanks, Ivan. Okay, right, yeah, so what we want to do is so we've got a client we can use to prove the behavior of our dictionary, but we don't want to call that service during our tests because we want to build to be solid. Relying on the third-party stub means we depend on the uptime in order to build to pass, etc., etc. So to get around this, we can build a fake version of the dictionary that will allow us to test locally with confidence. You can test on your machine, you can test on the train, and this is where the http4k model really starts to shine again, because the toolset makes it incredibly simple to build these types of fake systems. And once again, because of this universal, uniform server as a function server client model, these can be run totally in memory or simply started as a server that can be locally run or in a deployed way. So one very important thing when using fake is to ensure that it behaves in the same way as the real thing, because otherwise, what's the point of it? So how will we go about that? Well, we can simply reuse the same contract testing mechanism that we had before to prove that our behavior matches the real thing. What's more, we can also add failing tests into the fake implementation in order to see how our client would behave when the dictionary service blows up. And that's obviously something that nobody is going to write their app in order so you can make it do a 500. It just doesn't happen. So what would our domain client do if we did get a 500? If we stub out that adapter, we've never actually tested what would happen in that case. But if we're testing completely end-to-end with the fake, we can actually prove what that would look like. So let's see how that looks. Again, Ivan, let's decode.
Yep. Cool. So we have our dictionary, we have our real dictionary test, and now it's going to be the same process we've done before, where we're going to extract some superclass, which will going to be our contract of the behavior we expect the dictionary to have in HTTP terms. So like we've done before, we're going to extract the handler, and the only test that we have at the moment is fake one. I'm getting the imports moved across, and like before, now we run that to make sure that everything is fine, and we can go ahead and create a second implementation now that's going to be for our fake dictionary. So the fake dictionary will be just an HTTP handler function that has just enough functionality for us to use in other tests. So I started by saying that our fake dictionary server is only an HTTP handler, and of course it doesn't work because it doesn't do anything yet. So that's why the test is failing. But if we add the root to call with the word, and there we can use some URI template there. So any word can be passed as the path, because that's how the real server works. We know that you can invoke it correctly. So the way we're going to make this behave one is we're going to start with a pre-canned set of words, and for all testing purpose, all these are the valid words that we can use. It's worth noticing that cat is not a word there, so that will probably cause a bit of a thing for the other tests, but we're going to get to that. And to make the actual functionality, the only thing we have to do is we have to analyze the input from the path. So we extract the word from the path, and we check if it's in our list of predefined words. And if it is, we're going to say it's okay. If it's not, we're going to say it's an invalid word by returning 404. And that's all we have, or all we need to have totally in-memory, good enough representation of a third-party system that we can use for testing. And running the test works fine. And we can extract this to be reusable. So the same way we did with our app, we're going to do for our fake dictionary. So our fake dictionary is just a function that returns an HTTP handler. So a routing HTTP handler is just a bit more specialized HTTP handler because it contains the information. But in fact, you don't even need that. So we're going to just put an HTTP handler just to make it clear. And we're going to move that to its own file so it can be reused. Yeah. And we can run all the tests, and everything works. So from all our assumptions of this third-party system, everything works as expected. And like Dave say, if we want to simulate how failures happen, the real server will probably not produce failures, but if we know from documentation, for example, how those failures happen, we can add those tests specific on the fake one and make sure it works. So let's go. And now we have to apply that to our new test. So now that we're going to apply the dictionary to our previous functionality, we're going to get the original test, the count words. And as you can see, the original sentence we're using there was the lazy, lazy cat. And for all these words, only lazy and there are valid. Cat is no longer valid. So we need to change the assertion there for this new information that we got. And now that test fails because it's still returning 4. So that should be the driver for us to introduce the dictionary in our sentence analyzer app. So let's go ahead and do that. So for the sentence analyzer app, what we tend to do is when you have a dependency on any third-party system, we try to get that injected in the app as an HTTP client. And that means that you can then choose at the time you're initializing the application, you can choose if you want a real one or a fake one. Then we create the abstraction with that HTTP client. So the dictionary abstraction that we had before. That our handler. So I'm going to start by extracting a function where the actual logic for the counting words happen. So that's the part that does on line 33, the request, body string, and split. what I want to do in this case is pass each word through the dictionary. So I'm going to pass the dictionary as a parameter there. To make it a bit better, I'm going to use into an extension function dictionary. So our dictionary now, even though it's a client, you can pass a request and it will bring back from the words all the valid words from the body. So in this case, the only thing we're going to do is filter the list of words from the body using the is valid. So we're using our abstraction, and in this case, that abstraction will tell us if each word is valid or not. So the final step there is now that we introduced that dependency on HTTP handler, it means that we have to choose. We are forced to inject in our application an HTTP handler in every single case. So in the actual main here, I'm going to put a fake dictionary, but in this case, you create a client similar to the real one, and you can talk to your the real third-party system. To make it compile so far, I'm just going to put the fake dictionary. And it means for all our tests, and especially the contract one, because the contract for our app doesn't care about a real dictionary. It cares about our dictionary abstraction only. We can inject the fake dictionary. Finally, for the remote test, we can choose for integration test. Do we want to use the real one, or do we want to use HTTP for our server, but a fake one to represent the third-party system? So you can pick and choose now where you use fakes or where you talk to the real thing. So let's run one last time. And there you go. It's all passing. And in this case, we're only using fake. So there's no way this test will be flake. And the final thing, we're going to run the contract one last time now for all our tests, remote and local. And there you go. And everything is passing. And this is something that you can achieve quick tests, non-flaky, and different levels. So in terms of our demo, that's it. Dave, can you just recap what we've done so far?
Yeah, okay, no problem. Brilliant. Okay, so yeah, so as Ivan said, that's kind of it for the demo. Let's just recap what we did. So basically, we managed to run completely in-memory tests, no port required. That means that we can write thousands of tests if we need to, and they'll all run super quick. We've got reuser test code. So we got code that we tested for like literally testing one endpoint, and we managed to reuse that in not just a whole app test, but we then also managed to use that against real services running on a port. We also did third-party dependency mitigation. So basically, we got around the fact of being flaky, and we managed to put our assumptions about how the contract works into a test, which we can run in our build to make sure everything is like super fast. And the other thing is that you can obviously, you can't make things fail in terms of the real server, but you can do that in terms of that fake contract. That's brilliant. Okay, so that's that for that slide. There's one more wrap-up slide, which is basically, so Ivan, next slide, thanks. So yeah, so as I mentioned before, everything basically in HTTP4k has been written purposefully to treat testing as like a first-class citizen. And apart, so there's actually loads more stuff and technologies that we actually wanted to show you today, but we've only got a certain amount of time. We could stay here for hours. Basically, so in terms of testing, we also got we've got a module that's based on the Netflix Chaos Monkey. Basically, what that does is allow you to dynamically or statically introduce failing behavior into any application, be that your application or be that another application. So you can wrap that fake dictionary if you want in a filter, basically, which will allow it to time out or throw a 500 or even crash JVM, and we can do that. You can control that kind of remotely over the kind of REST interface as well if you need to. We've got service virtualization. So service virtualization is a way of encoding HTTP contracts into markdown files, which makes them portable. So think like VCR or Pact. It's designed to kind of go and document APIs and then work cross-platform, basically. So work across language. You can take your HTTP contract in a markdown file, give it to somebody writing a Go service, and they can test against it. And also we've got in-memory browser testing as well, using WebDriver. There's an in-memory WebDriver, and there's also a thing called approval testing, which allows you to do kind of assertion-based testing kind of like contract testing, but on things that will be a bit more visual. So say user interfaces, or also it's good for encoding JSON contracts as well. So that's kind of it really for now. That's kind of time for questions probably, if Dimitri's got any questions. Check us out on http4k.org, or we're on the Kotlin Slack. We've got so much to talk about. We could talk about, like, we now, I think we support 17 backends now, 6 serverless backends, including all the major clouds, and 7 or 8 different types of server backend, Ratpack, Undertow, Ktor, all that stuff. We've got lots and lots of different modules which are really kind of quite useful, and things that we found useful. We generally tend to always write modules when we find that something we want to use and we want to reuse, and so we put it out there for people for the community to use. But apart from that, I think that is it. So thank you for me and Ivan, and Dimitri, over to you, I suppose, for test questions.
So there is a question: how would you test gateway timeout like Firefall?
I can take that one. So there's at least 3 ways that you can test this kind of scenario. So if you just want to worry about like the server returning a 404, you can just in the in-memory one do an HTTP handler. You write another test, and the fake dictionary, with the version of the fake dictionary that will just return 504. And with that, you can check how your abstraction will cope with that. Will it throw an exception? Do you use result? Does he actually just return a default value like true or false? You can test that in memory without actually having to wait effectively. If you still don't trust that, you can change your client on the real dictionary to have a version that actually takes longer. And if it takes long enough, you can trigger a 504, and then you can do the same assertion on the abstraction. The third one is you can create a proxy with http4k with like a couple lines of code. You can actually have a proxy that talks to the real server. And this proxy introduces latency. That's one of the things that Dave mentioned about the chaos filter. Is just a filter that you add that can introduce latency, can introduce particular errors, and so on. So you can pick and choose how you test. The good thing is, like, now you have options, and they are all not that different from each other in terms of API. The API is there. You use HTTP handler as a way to call your service. How it's going to behave, it's really up to what you care about.
Oh, sounds cool. And I guess it's just to clarify, it's all written in Kotlin, right? HTTP4k, and it can be used in Kotlin only. Can you use it from Java, for example, or is it multi-platform?
I'll take that.
So
it's
go.
Okay, yeah. Yes, multi-platform. Is it? Well, yes. So it is useful from Java. We make we use quite a lot of Kotlin functions, like extension functions, etc. That tends to manifest itself in different ways. So extension functions, for example, get compiled into static functions. So when you've got a filter, then another filter, that gets compiled into a static function called then that takes 2 filters. So it looks a little bit odd. It's perfectly usable. It's fine. It's just that we do tend to find that. I was writing it only yesterday. I was writing a Java version, but it is quite frustrating when you've got Kotlin on the other side. It's quite frustrating. With reference to the multi-platform call, we are currently kind of dependent on a couple of JVM things. So we're dependent on IO, so input streams, and we are dependent on datetime libraries. Now, both of those are being addressed in the Kotlin space, but it's not yet. I suppose we will make a bigger play for multi-platform when those things are there and they are stable. There's no reason why the model won't work across everything. We've just got to maybe jiggle the project into the correct shape in order to make it all compile and happy, I suppose, once we've got those APIs in place. But yeah, not sometime in the future, not yet, I think would be the diplomatic answer.
Yeah, cool. And maybe I guess a question about performance, because if everything is so functional, is it really fast? Yeah. Do you have any benchmarks how well it works? Considering that it's like request response are immutable, everything is immutable.
Yeah. So our performance, because we don't do anything fancy, is just a thin layer on top of anything else. We find that the performance is pretty much constrained by the underlying backend. So it depends on what you choose to run your server, to run your client, mostly. The overhead is very low. So we run the tech empowerment benchmark. I don't know by head what's the result. I know they're pretty good. Dave, you probably remember better like how we placed on those. But I know that the performance in the Kotlin side, we are definitely up the top there. Dave, do you remember like which backend was the best one? I can't remember.
Yeah, so the best one in the round 19 was the Apache 4. I think Apache 5 actually came out as slightly slower. There are various, we try. There's so much you can do in terms of performance. I mean, there is no worries in terms of actually in performance at all, especially compared to some of the heavier frameworks. And what I would say is like with instant startup time and really small jar size. So the main jar file is basically less than a meg. You can get, especially if you deploy to Graal, which we support out the box, you can get those binaries down really, really small, and the startup time even faster. And yeah, so there's a whole plethora, there's a whole world out there to kind of to explore. There's absolutely no worries from, especially any of the applications that we've ever written in it, which is a lot. So.
Cool. Thank you so much. As you can see, I am back with you, and it means that it's about time to wrap up the talk soon. I thank you a great deal. I watched the entire thing. There were a few like video glitches, but they were insignificant. But wow, I am truly impressed. The way, especially like the code, it reads very, it's really straightforward, very easy to understand. And I think what I liked most is exactly what you just discussed, the performance. It does look like you can just do most of the stuff in memory. And I'm happy about it. I really should try it. Because before that, in different approaches, you would have to, get up a whole application with this Spring context and whatnot, for example. But here it's easy. I guess you don't even need test containers, right? Would you have any use for those? No. Cool.
It's just calling a function.
Yeah, exactly. Yeah, exciting. And the real TDD approach of the talk itself and all the demos. Thank you for that. So I guess there was not all that much activity in the chat, but I suppose there will be people in the discussion zone. So there is a link to it somewhere underneath this talk for the audience, and you will get the special links. Dmitry will be the moderator. He will get a very special link, and the rest of you can join and then have fun chatting with the people. So thank you so much.